I'm Chris, and this is the third video in the series of particle physics. In this video, we will be taking a closer look at the standard model of elementary particles. In previous video, we discussed about matter and various composite particles. If you haven't watched that video, click on the right top corner. Before going to the elementary particles, let us see what an antiparticle is. In particle physics, every type of particle is associated with an antiparticle with the same mass but with opposite physical charges. Thus, fermions have antifermion, quarks have antiquarks, and so on. This is the standard model of elementary particles. There are 8 columns and 4 rows. Traditionally, we have only 5 columns, but this is the extended model including the antiparticles. The first 3 columns in the model are fermions. On top, we have quarks followed by leptons in the bottom. Quarks and leptons are divided into 3 generations on the basis of their mass. In case of quarks, we have up, char and top quark with charge 2 by 3 and spin half. We have down, strange and bottom quarks with charge minus 1 by 3 and spin half. If you see antiquarks, you will notice that the mass of each particle along with the spin remains the same, but the charge are now reversed. We have anti-up, anti-charm and anti-top with minus 2 by 3 charge, anti-down, anti-strange and anti-bottom with charge plus 1 by 3rd. Now leptons. I'm sure if there is anything you are familiar with, it's the electron. And electron is the most important particle in leptons. Then there is muon and tau with increasing mass. All three have the same charge of minus 1 and spin half. We have 3 neutrinos: electron neutrino, muon neutrino and tau neutrino with 0 or neutral charge and half spin. If you observe the antileptons, you see another important particle. Just like electron is the most important particle in lepton, anti-electron, which is known as positron, is an important particle in antileptons. It is the only particle which has its own name in antiparticles. So antileptons are positron, anti-muon, anti-tau with charge plus 1 and spin half. Then we have electron antineutrino, muon antineutrino, tau antineutrino. They are neutrally charged with spin half. If you have noticed, all fermions and antifermions have spin half, and that is the characteristic features of fermions. We are done with matter now, and we will go to force carriers or elementary bosons. We will be discussing force carriers later on, but let us get a basic idea. Bosons are of 2 types: gauge boson or vector bosons and scalar bosons. First up, gauge bosons. There are 4 types of gauge bosons: gluons, photon, Z boson and W plus or minus boson. Photon has no charge or mass, but has a spin of plus 1. Photons carry the electromagnetic interactions. Gluon has no charge or mass either and has a spin of plus 1. Gluon carry the strong interaction. Z and W plus or minus boson carry the weak interaction, where Z boson has no charge and plus 1 sign. W plus or minus has plus 1 spin and plus or minus 1 charge. In scalar bosons, we have Higgs boson with charge 0 and spin 0. It is produced by the quantum excitation of Higgs field. It is also known as God particle. It is important in the entire standard model because it signals the existence of Higgs field. Just like fermions and antifermions has a spin of half, bosons have a spin of +1 with the exception of Higgs boson. Since we have gone through every particle in the Standard Model, you may notice the range of masses is very large. In fermions, neutrinos are the lightest, experimentally below 2 electron volt, rather in the range of milli electron volt. The top quark has mass as large as hafnium nucleus with atomic mass 178 and 72 positive electric charge. That's all about the Standard Model of elementary particles. Now we can answer an unanswered question. What are protons and neutrons made up of? In the previous video, I told you that they are made up of quarks. Now let us be specific. Protons and neutrons are baryons, that is, they contain 3 quarks. Protons are made up of 2 up quark and 1 down quark, and neutrons are made up of 2 down quark and 1 up quark. So, if you infer from the data, almost all matter is made up of 3 elementary particles: up quark, down quark, and electron, which is a lepton. It is not true that only these 3 particles make up the entire matter, yet these 3 particles are in majority. In the next video, we will be looking at the elementary particle quantum number and basic conservation laws. So see you till then.